All right, so today we're going to start our new chapter. Chapter 5 is going to deal primarily with triangles, and so we're going to start the first half of this chapter just working on what are the different types of triangles, what are the different properties associated with triangles, and things of that nature. And then the second half of the chapter, we're going to be talking about congruent triangles. So how do we tell if two triangles are congruent? How do we prove that two triangles are congruent? And so that's going to be kind of what we're looking at over the course of chapter 5 here. So the first thing we're going to talk about is the different ways we can classify triangles. So the first thing I can do is classify triangles by their sides. So are the sides the same? Are they different? And things like that. So what we're looking at is how are the lengths of the sides related? So in a scalene triangle, we have no sides that are congruent, meaning they're all three completely different lengths. So if you notice in the picture here, they have all three sides labeled completely differently. So 1 tick mark versus 2 tick marks versus 3. So what they're telling us is all three side lengths are different. That's a scalene triangle. Now compare that to an isosceles triangle. In an isosceles triangle, 2 of the sides are going to be congruent to each other. So that means I have 2 sides that are exactly the same, so 10 and 10 or 5 and 5 or whatever they might be. So 2 sides are the same, the third side is different. That's going to be isosceles. And then our third type of triangle is going to be equilateral. And with an equilateral triangle, all 3 sides are exactly the same. So one of the things you have to be able to do is look at the side lengths and determine what type of triangle you have happening. So scalene, isosceles, or equilateral. That's all based on sides. We can also classify triangles by angles. So what type of angles do they have within the triangle? So an acute triangle is one that has 3 acute angles. And remember, acute means less than 90 degrees. So if all 3 angles are less than 90 degrees, like we see in this triangle here, we have an acute triangle. An obtuse triangle is one that has 1 obtuse angle. And so obtuse, if you remember, was greater than 90 degrees. So anything larger than 90 is going to be obtuse. And so if we look at this triangle, we notice that it has 1 angle bigger than 90 degrees. So that's going to be obtuse. Now, equiangular is not a term we're going to use a ton. So the next type is equiangular, and that's just saying that all 3 angles are congruent. So if I have all 3 angles here, they're all going to be exactly the same. And so you can classify it as that, but it's also, because all 3 angles are going to be less than 90 degrees, it's also a different form of acute triangle. So when you're asked to classify triangles by their angles, that's just an acute triangle. But you'll see the term sometimes, so you need to know that that means all 3 angles are the same. The last type that's going to be an important one for us is the right triangle. And so in the right triangle, we have 1 right angle. And remember, in the triangles, that right angle is going to be denoted with that little box in the corner. So when you see that little box there, we have a right triangle. And then just to remind you, the right angle is 90 degrees. So you're going to be given problems where you're shown a triangle and they're going to say classify this triangle. So you need to tell me what type of triangle is it according to sides, what type of triangle is it according to angles. So is it a right isosceles triangle? Is it an acute scalene triangle? So what type of combination do we have going on for the sides and the angles? Now, as far as angles go, when we start talking about angles of a triangle, there's 2 different sets of angles that we're going to account for. There's the interior angles, which are the angles that are on the inside of the triangle. So that's what we see down here marked in red. So those are the 3 original angles of the triangle. We're going to talk about a specific property with those here on the next slide, but those are going to be some important things or important angles to keep note of. Now there's also a second type of angle called exterior angles, and that's what happens when we extend the side of a triangle. We create this angle on the outside of the triangle, which is why we call them exterior. And so when I extend all these sides here, we get these 3 exterior angles. And again, we're going to be talking about those exterior angles and how they relate to the interiors and things like that. So it's just a matter of knowing that there's inside angles, interior, and angles on the outside are exterior angles. Now for the interior, there's a really important property. This is something we use not only in this chapter, but pretty much every chapter from here on out. Whenever we have a triangle, the 3 angles in that triangle always have to add up to 180 total degrees. So this statement right down here says that the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180. So every time you see a triangle, those angles on the inside are going to have to add up to that 180 degrees. And so how we use that would be like on problems that we see here. So in this first triangle right here, So triangle number 1, they give us the 3 angles. We know that from the last slide, if I take all 3 angles and add them together, so x plus 87 plus 62, I have to get 180 degrees. So no matter what happens, those 3 angles have to add to 180. And so then if I want to know what my missing angle is, I can combine like terms. So I get x plus 149 is equal to 180. And then I can subtract 149 from both sides. X would equal 31. So when you're given the angles on the inside of a triangle, add them up to equal 180. Same thing on the other triangle here. So if I look at this triangle over here, I've got my 3 angles, one of which is a right angle, so that means 90 degrees. So don't forget to add that in when we're going through the 3 angles here. So we're going to take 2x plus 21 plus x plus 90 is equal to 180. So I've got all 3 angles added together to equal 180. So now when I go through and I start to kind of combine like terms, I can take my 2x plus my x and get 3x. 21 plus 90 would be 111, and that's going to equal 180. So then when I subtract 111 from both sides, 3x would equal 69. And then if I divide both sides by 3, x would equal 23. And then I could plug x back in to find any of the missing angles in the picture. Now this corollary at the bottom, so this corollary that it talks about is saying in a right triangle, so for right triangle specifically, because we always have a right angle, so we always have one of the angles that's 90 degrees, what they're telling us is that the 2 acute angles, so this 2x plus 21 and this x, the 2 smaller angles, always have to add up to 90 degrees. So up here, we took all 3 angles and added them together to equal 180, but since it was a right triangle, we could have taken 2x plus 21 plus x and set it equal to 90 that way. When I solve, I should get the same answer, so I combine 2x and x and get 3x. Subtract the 21 over, I get 69, and then 3x, when I divide by 3, x would equal 23 still. So with right triangles, you actually have a couple different options. Now, for me personally, I prefer not to use this corollary so that I know every time I see a triangle, I'm going to add the 3 angles to equal 180. Then I don't have extra information to memorize for later. So add up the 3 angles inside, set them equal to 180, solve. Now here we come back to those exterior angles. So we said there was interior and exterior angles. So now what's happening here is on this triangle, we're extending this bottom side. And what that does is it creates this angle on the outside of the triangle. And so one thing that is going to happen here is when we create this exterior angle, one thing to note is that that angle and the angle directly next to it, so in this case angle 3, those angles are always going to have to add up to 180 because they're a linear pair, which is something we've been talking about the last couple chapters. So I have angle 3 and angle 4 have to add up to 180. So that's a relationship you may or may not need to use within a given problem. Now, the other thing that happens with these exterior angles, so we have this exterior angle and then we have the 2 angles that are furthest away from it. So we have this angle 2 over here and this angle 1. So we already said how 4 and 3 relate, and that's that they have to add to 180 because they're a linear pair. Now, the exterior and the remote interior angles also have a specific relationship. When I'm given an angle on the outside, so when I create this exterior angle 4 here, if I can identify its remote interiors, so the 2 interior angles that are farthest away, so in this case angle 1 and angle 2, what we see, and ignore this, the formatting got messed up, is that if I take the measure of angle 1 plus the measure of angle 2, I get the measure of angle 4. So my 2 interior angles are always going to add up to equal that 1 outside angle. So not only do we have the linear pair with 3 and 4, but now we have a second relationship. The inside angles that are farthest away add up to equal the outside. And so again, we use this to kind of solve for missing angles within our pictures. So we've got this first scenario right here where we have 123 for the exterior. Now what they're giving us are the 2 interior angles that are furthest away. And so if I take those 2 furthest away angles, x plus 62, that's always going to equal that 1 outside angle, 123. And so now I can go ahead and solve for x. I subtract 62 from both sides. X would equal 61 degrees. Now what I also could have done with this particular problem is I know that the angles next to each other, angle 3 and 4 from that last slide, have to add up to 180. So what I could have also done here is I could have subtracted 123 from 180 and get 57. And then I know that all three angles, x, 62, and 57, all have to add up to 180. If I were to set that up and solve, I'm still going to get the same answer of 61, but we could do it a little bit quicker using those remote interior angles. So there might be more than one way to solve some of these problems. Now in the second example though, this one is not one where we can kind of do the 180 minus to find this interior angle because we don't have an actual angle measure here. So what we have to do is we have to use these remote interior angles, so the ones farthest away. So if I add those two inside angles, x plus 80, they have to equal the 3x minus 22. And so then when I solve this, if I get my terms together so I can subtract the x over to the right and get 2x, I can add the 22 to the right or left and get 102. When I divide both sides by 2, x would equal 51 degrees. Okay, so 2 insides are going to always add up to equal the 1 outside when they're the furthest away. So with that, you should be able to work on the 5.1 worksheet, which is the assignment, so you can get that in class. If you have questions about anything on there, you can always ask in class or email, or check the answer key when it becomes available. But everything on that worksheet should come directly from some of the examples that you see within these notes here. So you should be able to do that, and like I said, if you have any questions, let us know.